architecture. We are pleased to have him with us today as he presents the great refactoring, navigating the modernization wave. Can we have a loud round of applause for Sandeep, please?
Am I audible? Yeah. Hi, everyone. My name is Sandeep. Okay, here it is. Yeah, I work as a solution architect at Einstack. At Einstack, we build serverless and AI applications. Of course, now everybody is building AI applications. So when we started off with serverless, it was quite an obvious choice. So when I started my career, I used to carry servers around to data centers, install them, get the application running. From that point, when I saw serverless and AWS, it was no-brainer. And now looking at AI, again, it's a no-brainer, right? It is going to reduce the amount of work you do. So it's an obvious choice that you will be moving to that. So what we're seeing happening is this movement called the Great Refactoring. Just like how the automobile industry went through the Industry 4.0, where everything became about robotics, what we're going to see is how all the applications are going to be modernized using the AI. Previously, it used to take a lot of time and effort for you to modernize these applications. But now, everything is more accessible, everything is more easily doable, and a lot of it can be parallelized. So what we will see happening is all these companies which were hesitating to do a modernization because it's time-consuming, because it's complex, will all now jump into the race to see who can modernize faster, better, and make more value for the business. As we see this happening, all this movement, this is what we're calling as the Great Refactoring. Now let's talk about what used to happen yesterday. Yesterday, modernization was all about taking your stuff from your data center to the cloud. Think of it like you're moving to different houses. So you have boxes of stuff, and you're taking that box and putting it in a different place. Although your job is to kind of clean up what's inside the box, you just don't have the time, and you don't know what's inside that box. But you still move it anyway. If you don't, then you're probably going to get screwed from your mom, because that's her box. But it works, right? Moving to the cloud helps you save time. It reduces the cost, so it works out. Eventually, people realized that that's not the most efficient way to go, and then we started refactoring these applications. So with the refactoring, all of it is, again, manual. So any application that needs to be refactored, you start looking at the code base. The code base is already dead. The code base is already like 6, 7 years, 8 old. And then you start trying to make sense of what is happening inside these applications. It is a lot of time. It's a lot of effort. And then you start writing documentations. You create a business plan. It goes to the chain of command. Again, all of this taking a lot of time for you to get it done. And eventually, by the time you do it, it's going to be about 6 months for us to get anything done. All of this was done for one main reason. It was about automating, or it was about reducing your time. You started building CI/CD pipelines to make it easier for you to deploy. Gone were the days where you had to log into the server to copy the code into a specific folder to get it working. It was about getting observability so you can reduce the amount of time you spend in debugging. All the tools, technologies that came into place was always about reducing the amount of time and effort it takes for you to do something and make sure the system does it for you. Again, everything was about human-driven. Everything was about we doing it manually, we identifying the bottlenecks, we identifying what are the issues, we identifying and architecting what needs to come next. Everything was dependent on us to kind of get it done. Yesterday, it took about 6 months. So let me give you a small example of one of the modernization projects that we did at Einstack. So it was a large code base. The application had about some 25 different modules. And our job was to modernize this entire application. Now, what we estimated was it's going to take about 6 months, because every package that was used in that application is now obsolete. And we are having sneak issues. There were security issues, and everything blown up. So we had to pretty much rewrite everything. So we started off with one module. We understood what is there in the code base. We understood what kind of architecture was implemented. We took that and started doing it manually. We did use Claude, but we used it at a very surface level. We just said, take from this version of the application to put it to this version. Obviously, it failed. and we didn't have the time to kind of see what's happening clearly. So one of the teams, or say part of the team did that work, which is basically doing everything manually. The other team started observing what these people are doing manually and getting the context out of it and started building agents on top of it. And what happened after that is the rest of the 24 modules, we did not write it manually. We just gave it to Claude. So by that point, we had built the system, or we had built agents, we had built MCPs, everything with specific context on what is there in the code base, what needs to happen, what is the code base structure, what is the architecture, all specialized tools, everything to help us make sure that the context was limited and it could autopilot its way into getting things done. Rest of the 24 modules we completed in about 6 weeks. That is how fast you can move by making sure you give smaller context to LLMs and orchestrate them properly. Today is all about using AI to accelerate your development or your modernization. It's always going to be about you fighting against somebody who's doing it manually versus fighting against somebody who's going to do it in an automated fashion. Again, everything revolves around automation. Everything revolves around making sure your time is saved so you can focus on better things to do. So this is about what was today. What's going to happen tomorrow? Tomorrow we will see this technology evolve into a lot more maturity. We will see things like agent repositories. So think of this like NPM or pip, which are these package managers. Now if you want to build an application, you just look up the relevant packages, install them, and get things done. The same thing is going to happen with agents. More and more players are going to come into the picture who are going to give you these tools, or there's going to be more open source projects, open source agents, which you are going to probably just install or hook up to your application and get things done. We will see new coding patterns emerge. We are already seeing things with spec-driven coding, context engineering. But what we will see happen more and more is you're going to get more structurized coding methods. You'll have things like JSON programming, where all you have to do is evaluate the JSONs, because it makes it much more easy for you to review what's happening, because you will be spending less time writing the code and more time reviewing what's happening with the code. We will see new architecture patterns. We will see new blueprints that are coming up. These are, again, going to be shareable, reusable. One of the announcements in the AWS reInvent was they transform, and they already have started creating these blueprints, Angular migration or front-end migration, things like that, which is going to make it, over time passes, we'll see new blueprints that are coming up which are more reusable. It'll always be about AI-driven systems. It's always going to be about self-healing, self-automation. Everything is going to be driven by AI. All you will be doing is directing it on what it needs to be done, and most of the work will be taken care by these systems. Now, what is going to happen is we are slowly moving away from writing the logic, the business logic, to telling the AI what needs to be done. Now, for this to work properly, you need to make sure that all the context is properly defined and given to the AI. We are moving away from writing the actual code to orchestrating a bunch of agents to write the code for us. We are eventually moving from us writing everything, infrastructure and all those things, to an AI going to do all of this work for us. Now that brings us to the question. All of us here are probably experienced, right? And if AI is going to do most of our job, what is left there for us, right? But this is where it gets interesting. Everything that you have built, everything that you have learned over the years is what is going to help you design the systems today, so you don't have to worry about it tomorrow. I want to tell a short story on how I started coding. So I'm from an electrical background, so I don't know anything about IT. So in one of the very first interviews after my college, the interviewer asked me, "Can you create an IAM user?" I said, "Yeah, go to the console, click, 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 and it's done." And he said, "Okay, now create 1,000 users." And I said, "I'll have to do the same thing 10,000 times." And he said, "No." Obviously, I was rejected from the interview. And then he said, "There's something called Python, and there's something called Boto. go see what is happening over there. That's when I started coding. Before that, I had no interest in that. And today, I'm going to ask you a similar question. Now, if you want to modernize an application, you're probably going to sit on the system, understand what's happening, do everything manually. Tomorrow, if you want to modernize 1,000 applications, are you still going to do it the same way? Lastly, we are the chosen ones. You and I are in a very special place where we get to dictate how this technology is going to evolve. All the new blueprints, new coding patterns, the agent repositories are the ones that are going to come from us. We are going to design these systems that are going to help the next generation of developers, architects, to move forward. So let's make sure we build a wonderful future for them. Thank you.
I have one question about the migration part.
Yeah.
So was there already test cases for the earlier modules that was there? Was there already test cases for that so that when you have done the migration, you would be able to verify whether all the test cases are correct? Because since it's a legacy project, it's not the case that every small test case would be verified, and it could be the case that there might not be test coverage for everything.
Yeah.
So how do we verify that whatever generated by the LLM is exactly what you need?
Yeah, so in this specific case, there was no test cases at all, like nothing. So what we did is we went through the application, created the test cases first, and then we did the migration, then we validated against those test cases to see if it's all working properly.
Okay, so in that case, the first step would be to manually identify the business scenarios through the code itself, and therefore we would need to review the code initially with the help of AI, and then we would need to do the migration like that.
What we also did is, right now there are a lot of front-end related agents that are available, extensions as well. So you can just give it access to the application, ask it to create a bunch of test cases. It's going to go through all the flows, all the patterns, and then tell you how the system is working now. And you can use those test cases. Playwright has wonderful agents available. So you can do all that work before you do the actual code shift, unless you have the test cases already there. Right? If it's there, it's easy for you to do. Else, you need the test cases first in place, and then you start the code change.
All right. Thank you so much, Sandeep. Please stay on stage. I'd like to invite Sharika on stage to hand over a small